Hello everyone, we are Smartdrive and we're gonna present the hyper detection with artificial intelligence. By us.
Introduction. Integrated project. This is an intelligent system. This will use to for car detection with convolutional neural network CNN. The goal is to develop a car detection system in the image with a CNN that achieves 90% accuracy in 4 months, based in deep learning tools and public data. Yeah.
So, with the paradox of defined project requirements and constraints, we have 3 points of requirements. Object detection capability, image input handling, model training, and the constraints we have 2 points. Hardware limitations and budget constraints. That means we have 3 requirements to develop a good project and 2 constraints will limit it.
The next point is evaluation dimensions. The first point is technical. The technical, we have 3 points, is model accuracy, computational efficiency, and model robustness. The next point is operational. Have other 3 points. Ease of implementation, data management, and platform support. And economic is deployment cost, licensing and maintenance, and return of investment. And the last one, this risk, other 3 points, is technical, data, and dependency.
So, the next point to abord is candidate technologies. We have 3 different technologies to use. YOLO V8 with an advantage to real-time high-performance object and detector, but only in the CPU. The second one is faster RCNN. It's very accurate with a research rate, but slower in the real time. The last one is ECCD. It's single-shot multi-moment detector with a good balance model for the mine per minute. But this is only in the simulation. So the last one is the worst for the project.
About the optimal technology for intended purpose, we have the technical performance where the achievements have high accuracy. So, have spent of mid-range about the GPUs. Meanwhile, the operational efficiency is easy to implement, to train and to deploy using ultra-regex, and API works seamless with the OpenCV and Flask. And the economical facility is about fully open source, minimal hardware and low cost, optimized models available for each device.
The other point is cost and benefits analysis. The first point is model development. We can improve and upgrade our model. Detection accuracy is the other point. This point is very important because we have a good accuracy with this AI. And the last point is community and support. We have many people that work in support and we have a good community in this project. Okay, the other point is hypothesis and measurable variables. The first point is research technical hypothesis. These have 2 points. This processing speed hypothesis and economic feasibility hypothesis. The other point is measurable variables. The risk is error rate, system, or downtime. And the other risk can be economic, for example, the prototype, the cost, and resource and utilizations. And the other point, the final, is experimental validation plan, this prototype testing in lab environment, and also user evaluation.
Well, here we have the data collection and analysis plan. So, we have targets where is viewed a representative dataset for training, validation, and test that reflects the reality below between the conditionals, day-night, weather, occlusion, camera, and other types. We have the data source and a question plane where we use public datasets, baseline where augmentation, COCO-CAR class, KTTL, Pascal Bok, labeling and additional protocol. Boxes tick around the visible vehicle body, exclude mirrors and only if invisible. Reporting and dashboard. Fuel validation report. Per camera metrics, scenario, breakdown, uptime, incidents. And the acceptance criteria. Training validation test. Datasets created by versions. Analysis experimental results. Potential test and uncertainty. Bootstrap CLS format. And per class AP. Recommended. Realized image. Recomputed AP. Error analysis. For the top failure models, create a rank table with counts. Reporting. Exclusive, summary, pass-fail, and K numbers. Lab metrics and EPIs. Per curves. Confusion matrix and per class APIs. Example, interpretation scenarios. Best class lab map. Native for fuel map 92%. Latency P95 and 13.5 ms. Uptime 99.9. Clear pass advance to TRL8 and play pilot scaling.
3.
Theory 7 System Prototype Demonstration in Operation Environment. Key points can make CCTV installers. System with tray interior cards. Cold service field. And city campus labs that give data and pilot samples. Key activities. Collect and label images and clip with cards. Design, train, test, and tune CNN models. Set up pilot sets. Test on file. Fix edge case. Key assets. Database sets with card image from many scenes. CNN model and code. And depth team knowledge. Unique power offer. High extents card detection on common cams using CNN. Work with video feeds that already exist. No new sensors. Lead alerts and stats counts. Density range use. Parking space used. Customer relationship. Public and private marketing. And big firms with own fleets and yards. Channels. Allied with CCTV installers and system integration. Demo and pilots in campus, parking, and small city zones. Client segments. Public traffic and city units. Parking lot, films, logistic and field firms, and security and CCTV firms that buy smart video tools. Cost setup, model training, depth temp, code use, and install and support from clients. Income lines, design and income, could use fee, setup back, and custom add-ons. Finish.
Well, about the prototype, it is works, for example, with a camera IP, where you put a camera server, it's sent to the server to a script, and the script starts to work to identify in real time the car. For example, if you show a car from Toyota, it will to recognize it how Toyota, and if you show the other type of car, it will show the other type of the car. About the Tier 8 system complete and qualified, we have defined system validation real-world operational, compliance with all technical, functional, and operational requirements, the documentation complete, repeatable and stable results, and ready for pre-production or operational pilot testing.
Conclusion, Smartdrive Ai successful demonstrates who cumulate. Okay, repeat. Conclusion, Smart AI successfully demonstrates how convolutional neural network CNN can enable accurate and efficient reticle detection. Among the test models, GUTIERREZ proved to be the most efficient, offering highly accurate, real-time performance, and low implementation cost. Overall, the project shows that AI passive detection system can enhance traffic moderation and support smart, safer transportation solutions. Thank you so much.